Solving an equation. First, we have to determine what kind of equation we have. When we analyze an equation to determine what type it is, we need to look at the variable and look at the exponent on the variable. In this case, the highest power of the variable is 2. That tells us we have a second-degree equation, a quadratic equation, also another name is given to it. And when we solve this kind of equation, the method we have available to us now is factoring. In order to use factoring, we must have all of the terms of the polynomial on one side of the equation and 0 on the other side. Once we have that equation in what we call standard form, that's what's called writing the equation in standard form. Once we have the equation in standard form, then we factor the polynomial that's present. This is a trinomial. Remember, when you're factoring, the first thing you want to look for is there a common factor that we can factor out. And these three terms do not share a common factor other than a 1. So we can't divide out a common factor. Trinomials, if they factor into the product of two binomials. We now want to put in the signs in the binomials. Remember, we look at the second sign of the trinomial. If this is an addition, additions only come from either having two subtractions or two additions in the binomials. To get a plus, it's got to be a plus times a plus or a minus times a minus. And to know which one you have, you use this sign. Since this is a minus, it's going to be two subtractions in our binomials. When we're factoring trinomials, then we look at the first term of the trinomial to see what its factor pairs are. To get x squared, that would be x times x. Then look at the third term of the trinomial to get its factor pairs. To make 15, that would be 1 times 15, or 3 times 5. Now remember, the process of factoring then is to pick a pair from each of these groups, put into the correct locations in the binomials, test with the O and the I of FOIL to see if you have the right combination. The only pair we have for the first positions is x and x. Now let's look, are we going to use the 1 and the 15 or the 3 and the 5? And generally, I check the numbers that are closer together first. Let's try the 3 and the 5. Well, under the O of FOIL, that would give us minus 5x. The I of FOIL would give us minus 3x. Minus 5x combined with minus 3x gives us the minus 8x that we need. So we've factored the polynomial. Now we're looking to find the solutions. This quantity times this quantity is supposed to give us 0. The only way that happens is this quantity has to be 0, or this quantity has to be 0. So we are looking for a value of x that would make either this quantity become 0, or would make this quantity become 0. And these two binomial factors are relatively easy to analyze to figure out what value of x would make that happen. If we just look at this and ask ourselves, what could we put in place of x that would cause that whole quantity to become 0? Well, that would be 3, wouldn't it? If we put in 3 for x, 3 minus 3 would be 0, and 0 times anything is 0. The left side has become the same as the right side. We have a solution. So one of our solutions is that x equals 3. Now let's analyze this binomial factor. What number could we put in place of x here that would cause this quantity to become 0? Well, that would be 5. 5 minus 5 would give us 0. So if x was 5, this quantity would become 0, and 0 times anything is 0, and we have our other solution. Typically, when you have a quadratic equation, the highest power of the variable is 2. Typically, you will have two solutions. We don't always have two solutions. Sometimes we have one solution that's duplicated. But most often, we have two unique solutions. So here's a solution to a quadratic equation rendering these solution values for us.